before I let you guys go, I'm gonna go over the scientific paper in detail. So let me go ahead and open that PowerPoint right now. Okay, can you guys still see my PowerPoint right here? Yeah, okay. No? Okay, let's try that again then. Okay, can you guys see that now? Okay. So I will post this this lecture for the scientific paper on Blackboard. It's actually on your Blackboard site already, so you guys should be able to see this and follow along. Let me go ahead and start it from the beginning. So your scientific papers are going to be due on Wednesday, May 6th through Blackboard. And you guys are going to be turning it in through turnitin.com so I can check your plagiarism percentage. I had a question on the last class asking what I guess is in appropriate plagiarism percentage, because a lot of you guys are going to have, or all of you guys are going to have similar methods and results. Your plagiarism percentage might be pretty high, especially because obviously I have students from last semester that did this same exact paper. So around 30% to 35 is still okay. If it's 40 to 50, anything above 50, you definitely need to double check your paper. If it's 40%, 45%, I would double check it still just to be safe. But if most of your highlighted area and your plagiarism percentage is, let's say, like your tables from your results section or your methods, then that's okay. But if it's like highlighting all of your introduction and your discussion, then I would be worried. That's when I would really start to dock points. If it's over 50% and you submitted it early, my suggestion to you would be to do parts of your paper and resubmit it and try to get a lower plagiarism percentage. That way you don't lose points on that. So above 50% is a no-no. 30 to 35, you're still good. If you're in the 40 to 45% range, I would double check it. Again, if you're 40%, but it's mainly like your methods and your results, I wouldn't worry about it. Okay, so formatting. So the first thing obviously is going to be your title. It should be a pretty lengthy title that describes your experiment. The title is always what's going to grab the attention of your reader. So it should be pretty detailed and describe your experiment in a really succinct way. So this should be bold, centered across, and 16-point font. You do not need a cover page. You can just have your title at the top of your paper and you're good to go. I would say about 10 to 12 words is pretty decent for your title. It could be something like growing experiments using radishes and various concentrations of Hoagland solution, something like that. Descriptive enough where it describes your experiment and it'll grab the attention of your reader. Okay, and then below the title will be your name and your affiliation. All of your affiliations will be California State Polytechnic University, Pomona, and this should be written in 12-point font. The rest of your paper should also be written in 12-point font as well. The only thing that's going to be slightly bigger is your title. And your font should either be Times New Roman or Arial. But I know that Arial is slightly bigger, so if you guys are trying to cheat with the whole paper thing, trust me, been there, done that. Okay, and organization, that is key within each section. I'm going to talk about how each section should be organized in just a second. That'll really help with the flow and the fluidity of your paper as well. Okay, so the abstract. Now the abstract is a summary of your entire paper. So think of this as like the Cliff Notes version of your paper. So the title is what grabs the attention of your reader, but the abstract is pretty much makes your reader want to read your entire paper. So if your abstract doesn't catch their attention, they're not going to read the entire paper. So think of the abstract as pretty much like a Cliff Notes of your entire paper. This is going to be placed right below your title, your name, and your affiliation, but right above the introduction. So this section should be italicized and written in 10-point font. You're most likely going to be writing this section last after you have written everything else. And I highly recommend that you do write it last. It's going to be a lot easier for you to sum everything up once you have everything written. So a good rule of thumb for the abstract is to write about 1 to 2 sentences summing up each of the sections. So about 2 sentences for your intro, your methods, your results, and your discussion. In reality, you probably only need to write a sentence summing up your methods for the abstract, and everything else will probably be about 2, maybe 3, but probably 2. So again, your abstract is just summing up what you wrote. Okay, so now for the introduction. This is a step-by-step progression towards the goal and the objective of the study. So you're gonna wanna start with big picture topics and then narrow down to something more specific. So what I mean with big picture topics is maybe starting off with talking about why nutrients are important for plant survival. Maybe you can talk about the 17 essential nutrients, and then from the 17 essential nutrients, you can talk about the 3 important mineral nutrients and 3 important non-mineral nutrients and the roles that they play. And let's say you're talking about the 3 important mineral nutrients, which is nitrogen, potassium, and phosphorus. You can take that even further and more specific by talking about the certain roles or functions that they play for certain plants. And then obviously you're going to want to provide background information on Hoagland solution, what it is, what studies have been done with it in the past, how people who have used Hoagland solution in their study compares to how we used it in our study. So those are some things that you can talk about in your introduction. Again, you're going to want to start off with big picture and then slowly start to narrow down as you progress towards your introduction. So make sure to also obviously provide information about what other researchers have found when using Hoagland solution as well, and then how that compares to what we did. So with your introduction, don't talk about your objective / purpose right off the bat. You want to transition into your objective of the study by providing tons of background information. So providing context into what we did. So once you talk about all of your background information, then you can talk about your objectives. And once you've talked about your objectives, then from there you can go into your hypotheses, what you expected out of this study, what you expected your results to look like. For your hypotheses, you can think about whether you expected, there to be a difference between the full-strength Hoagland solution, half-strength Hoagland solution, and the control, which in this case was just DI water. And then within those 3 treatments, did you expect there to be a difference between number of true leaves, plant mass, shoot height, and taproot length? Maybe you have different expectations for each of those measurements, or maybe they're the same across all 4. But you're going to talk about those hypotheses after you talk about your objective. So talk about the purpose of the study, why you did it, what interested you, and then what you expected after the study was done. So never state your hypothesis directly as like, this is my null, this is my alternative, or H naught was this and HA was that. That is a complete no-no. Your words should clearly state what the alternative is, and then from that, your reader should be able to infer the null or the opposite, basically. So I have an example down here at the bottom. It was hypothesized that the radishes that received the full-strength Hoagland solution would have the greatest number of true leaves and the largest shoot, root, and plant mass compared to the plants that only received DI water and the half-strength solution. So your hypothesis can look something like that. Again, it doesn't have to be, your hypothesis doesn't have to be the same exact as mine. It could be different. But again, this is more or less how your hypothesis should be written. Okay. Now moving on into the methods. So before you start going into what the actual methods were for this experiment, always restate the purpose or the objective as your first sentence. So for example, to understand how plant nutrients affect the growth of radishes, 5 radish seeds were grown for a period of 4 weeks, blah, 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 blah. Does that make sense? So restate your objective first to remind the reader why you were doing this study in the first place, and then go into exactly how you did the experiment. So be detailed. You want to be detailed enough where if somebody else were to read it, they could easily replicate your study and do the experiment themselves. That's the whole point of why we publish scientific papers in the first place, so that other people can go ahead and do it and replicate those methods. But you want to be succinct and to the point. You don't want to add a lot of unnecessary details like what the weather was that day or what time of day you did the study. I mean, there are some methods where the time of day is important. Like, for example, if you're taking water potential, obviously if you took it in the morning or at night, that matters. But for this study, it doesn't matter. So just be clear and to the point. So remember, just like how you write your methods for the pre-labs, this should always, always, always be written in past tense, because you already obtained the results, which means you already have done these methods. So never future and never present tense. Always, always, always in past tense. And this should also always be in third person. So no pronouns, no I, no we, no you, just this was done, or how can you phrase this? 5 radish seeds were grown in pots filled with perlite and then grown for a period of 4 weeks, something like that. No pronouns though. Always written in third person. Okay, so some of the methods I have listed out for you guys here, because obviously there were things that you couldn't do because when we were about to start the experiment, that's when the lockdown happened. So you really want to explain how many radish seeds were used in each pot, which was 5, how long they were grown for, which was 4 weeks, how often the radishes were watered. Obviously you guys didn't water them. Lauren, the other TA, and myself watered them. We watered them about every 1 to 2 days, depending on if the perlite was still really wet. But yeah, so these are some examples of what you can put into your methods, really what you should put into your methods. If you need a bit of a refresher, the Lab 8 manual is on Dr. Brovich's lecture site, so you guys can go ahead and look at that as well. That'll help you write your methods too. So also keep in mind that on the first week of the study, when you guys first potted your seeds, all radishes, every single one, whether it was half full or control, were watered with DI water first. And then on the second week of the study, that's when we started watering them with their respective solutions. And this experiment lasted for a total of 4 weeks. Once the 4 weeks were up, we harvested every single radish seed and we measured the mass of the plant in grams, the height of the shoot, and the taproot length in centimeters, and the number of true leaves were also recorded as well. And then from there, once you've talked about all those methods, then you can talk about the type of data analysis you run. So in this case, it was a single factor ANOVA. And from that single factor ANOVA, if you had a p-value less than 0.05, which for 3 out of those 4 measurements you did, then you also ran a post hoc test with a Bonferroni correction. And the post hoc test that you guys ran was a 2-sample t-test, assuming equal variances. And again, this was all done on Excel. So for the methods, you want to avoid bullet point style / cookbook writing as much as possible. And keep in mind that the materials should be written within your methods. It's not like a cookbook where you list out all the ingredients / materials first, and then you talk about how you did it. You kind of just nestle your materials within the methods. So keep that in mind. Okay, moving on to the results. This is the portion where you're going to report your findings. This is the part that everybody is interested in besides your discussion. So you're basically briefly summarizing the patterns and referring to the tables for the actual data results / values. And I'm going to show you guys what your tables should look like in just a second. But you're going to write out your results text first and then include all the tables below the text. So your results text, where you pretty much talk about what the data was, should really only be about a paragraph or 2. It really shouldn't be too long because you're only reporting / stating all the important findings and the major patterns. But all your results will be in your table. So you don't have to type out every single mean, every single standard deviation or p-value. Just talk about the more important findings because that's what the tables are for. But you are going to include all the ANOVA tables that you guys did and all the post hoc tables. In total, in your paper, you should have 8 tables, and I'll show you what those 8 tables should look like in a second. But keep in mind that in total for your results, you should have 8 tables by the end of it. Like I said earlier, you don't have to list every single result, only what was important, and you want to state the direction of significance, not just that there was one. So state whether there was a significant difference or if there was no significant difference. So you want to avoid repetition with the data and statistics as much as possible. I said this earlier, but pretty much like the means and the p-values, because that is what your tables are for. So when you're actually writing out your results text, one example could be, after growing the radishes for 4 weeks, there was a significant difference in the number of true leaves between the control, full strength, and half strength treatments. And then in parentheses, after that statement, you're going to include what type of test you ran, which in this case was a single factor ANOVA, and then that the p-value was less than 0.05, and then the table that you're referring to. So for number of true leaves, that could be table 1, maybe your shoot height was table 2, so on and so forth. And then if there was a significant difference, obviously you're going to want to talk about the results for the post hoc test. So one way that you could phrase it is The half-strength Hoagland solution treatment had a greater number of true leaves than the full-strength and control treatments, and the control treatment had a lesser number of true leaves than the half-strength and full-strength treatment. And then you would, in parentheses, talk about the type of test you ran, which was a 2-sample t-test with a Bonferroni correction, and then the p-value was less than 0.05, and then refer to the table that you're talking about once again. So really, you're not directly listing what the mean is, what the standard deviation is, because again, that is what your tables are for. So all table headings need a strong description, and these go above the table. If we had, so keep this in mind for future labs when you're writing scientific papers, if you have figures or graphs, those headings are always going to be below the graph. Whereas if you have tables that just list out numbers and such, those descriptions are always going to go above the table. You're not doing any interpretation of your data whatsoever. You are simply stating what it is, if there was a significant difference or not. You're not drawing any conclusions at all in the results until you get to the discussion, which is basically the meat of your paper. So again, you're just stating what the results were for the results section. Okay, so for the discussion, again, like I said, this is the meat of your paper. This is where you talk about and interpret your data and talk about the biological significance. It is okay to repeat your results, but only in the context of explaining them. You don't have to repeat your results all over again in the discussion, as again, that's basically what the results section was for. So you could always just refer back to your tables in the discussion. So in your discussion, you want to talk about each major pattern, explaining why you think those patterns occurred, and using literature and past research to back up your points. So reading through other primary literature, other books, journals, looking for journals that maybe did maybe not an exact same study, but a similar study to what we did, and how their results either were different or similar from ours. So I have a few pointers down here at the bottom for your discussion. Did other studies have similar results? Did they have different results, and if so, why? If there was no significant difference for a particular measurement, in this case, the one measurement that did not have a significant difference was shoot height. Why do you think there was no difference with that? If there was a significant difference, which there was for true leaves, taproot length, and plant mass, but let's say only one group was different from the rest. Why do you think that is? If only one group was different from the rest, maybe their average was higher or lower. So look into that for your discussion. Think about why too. So maybe, for example, the taproot length, there was a significant difference, but let's say the control actually had which only received DI water, maybe the control had the longest taproot. Why is that? So think about that. Okay, never undermine your results. Don't spend a whole paragraph talking about what could have been done better, or we should have done this, or maybe we didn't do that, or whatever. Nobody cares. Just talk about what this research provides and how it could be used for future studies. So again, do not undermine your results. So reduce spending a lot of sentences too on affirming or rejecting your hypothesis. You don't have to say, so we reject the null, or we accept the alternative, blah, 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 in the discussion. Just interpret the data as best as you can. Okay, and then finally, for the literature cited, you need at least, so a minimum of 5 sources cited from primary literature. So that's books, journals, etc. A good place where you guys can get journals is obviously Google Scholar or JSTOR. If you set your Google Scholar to Cal Poly Pomona, you're going to get a lot more access to certain journals. If you log in through the library Cal Poly website, you also have a lot of access to journals there for free, where you can download the PDFs. The literature site is going to continue right under your discussion, so you don't have to start a whole new page for this portion of the paper. Each citation should be single-spaced and have a hanging indent. And I've also included the format for how your citations should look like, depending on how many authors there are. So here's the format for 1 author, 2 authors, 3 or more authors, so on and so forth. Also, one more thing for your in-text citations. If you're doing an in-text citation and there's only 1 author, you would only include, for the in-text citation, it would be the author's last name and the year. If there's 2 or more, you would say, let's say it's like Dr. Bobich and Dr. Ewers, it would be Bobich and Ewers 2008, whatever year that paper was published. If there's 3 or more authors, let's say it's like Dr. Bobich and like 5 other contributing authors, you don't have to list every single author in your in-text citation. Obviously you would for the actual literature cited, but for your in-text citation, it would just be Bobich et al. And then whatever year that paper was published. Et al. Basically means like their entire posse for the paper. So that's how you would do an in-text citation, and I've included the formats here for your literature cited, again, depending on how many authors there were for the paper. Okay, so like I said, this is already posted onto your Blackboards, but I'm gonna go ahead and show you guys what your papers, or not your papers, what your tables should look like for your scientific paper. So let me go ahead and pull that up really quick. But like I said, you guys should have 8 tables total for your scientific paper.
Do you have the tables up right now? Or?
No, I'm pulling it up right now. So
oh, okay.
Yeah,
sorry.
I can't see it. So I'm going to pull up the tables and then the Excel sheet as well. Give me 1 second. Oh, and one more thing, don't forget that your pre-lab quiz is also available already. It's the same exact structure as last week. 5 questions worth 1 point each, and then you'll have 7 minutes total to complete it. It's just downloading, give me a second. Also, if you guys came in a little bit late, I already graded all of your nutrient lab assignments. So go ahead and double check that. If I didn't leave a comment on yours, it means basically all of your values were correct. But if I did, just make sure to double check that. Some of your values might have just been slightly off. Sometimes that also could have been a copy paste issue. So if I did leave a comment, just make sure to double check that. Okay. I have the Excel sheet up. I'm just pulling up one more thing to show you guys. Here we go. Okay, let me stop this share really quick, and then I'm going to do a new share. Okay, so can you guys see my Word doc right here? Okay, so this is what essentially your tables should look like for the scientific paper. Like I said, there are 8 total. So this right here, the first table at the top, again, you don't have to order it the same exact way that I did. You could do shoot height first, taproot length first, whatever you want. But I just did true leaves first because that was the first sheet in the Excel document. So your first table will just be this ANOVA portion. So where the part of the table that displays the p-value, the f-value, degrees of freedom, etc. So you're not including the portion of the ANOVA table that has like the means and the variance, etc. You're only including this bottom portion of the table. So again, the one that displays the p-value. So that'll be one table. If you ran a post hoc test, which you guys did for number of true leaves because the p-value was less than 0.05, what you're gonna pretty much do as your second table, instead of copying and pasting every single one of those tables into your paper, the part that we only cared about anyway within those tables was the two-tailed p-value. So what I did instead was just made a simple table, which you guys can see here that I have highlighted. So I have like control versus 0.5, control versus 1.0, and half versus 1.0, and then I just copy and pasted those respective p-values and made them into one table. Does that make sense? Okay, so that'll be your second table. And then your third table will be whatever the next ANOVA table is. In this case, I have shoot height. But remember, for shoot height, because the p-value was greater than 0.05, you did not need to run a post hoc test. So from there, I would move on into the next table, which in my case, I have taproot length. Again, you only want the bottom portion of the ANOVA table. So the part of the table that has the p-value, which I have highlighted here. You do not need to include the portion that displays the means and the variance, etc. You can forget about, well, not forget about that part, but at least for the next ANOVA table, only the part that displays the p-value. Does that make sense? Okay. So that will be your next table. And then again, for shoot height, we did run a post hoc test because the p-value was less than 0.05. So once again, I pretty much just made a separate table with control versus half, control versus full, and then half versus full, and then copied and pasted those respective two-tailed p-values. And then finally, we have plant mass. Once again, I just copied and pasted the bottom portion of the ANOVA table, which is just the p-value, and then made a separate table with the post hoc test. Your last table is going to be the means and the standard deviations, and I'm going to show you guys how to do this right now. So let me stop this share really quick and move on to the Excel. Okay, so can you guys see the Excel sheet? Okay, perfect. So I'm gonna go ahead and make a new sheet. I'm gonna label the top row right here with the measurements. So we have true leaves. Next column, I'm gonna do shoot height, taproot length, and then last column is going to be plant mass. So that's gonna go at the very top. And then right here on the first column, I'm gonna do control, 0.5 Hoaglands, and then 1.0 Hoagland solution. Everybody with me so far? Okay, so what I'm basically gonna do is I'm going to copy and paste all the means into this one singular table. So right here, I'm on the sheet for number of true leaves. So in the ANOVA table, remember that when you guys are putting in your tables into your paper, this is the only part that you're gonna copy and paste into your paper. And then for the averages, this top part right here, we're just gonna go ahead and copy and paste these averages. So copy, edit, paste special values into this one table right here. Make sure that when you are pasting it into this one singular table, that you just don't press paste, because sometimes it'll change your values. I actually noticed that it did change some of your values in your Excel sheet. I did leave comments for you guys if it did. So just make sure instead of just pasting it straight away, just do paste special and then values, and it won't change at all. So just make sure to do that. And then you're gonna go ahead and do the same thing for shoot height. Just copy and paste special those values, and then do the same thing for taproot length, copy, and then paste special the values. And then finally for plant mass, once again, just copy and paste special the values. Okay, everybody with me on the averages so far? It's just simple copy paste. What about in the chat? Everybody okay so far? Yeah? Okay. Okay, perfect. So now I'm going to show you guys how to calculate standard deviation. Super, super easy. So in the ANOVA table that you guys ran, it already shot out the variance. The variance and their standard deviation tell you the exact same thing. It tells you how spread out or how variable your data is. So if a lot of your data points are really close to the mean, you're going to have a smaller variance or standard deviation. If it's really, really far apart, like you have tons of outliers, your variance or standard deviation is going to increase. But the reason why we're not using this variance is because it's basically not in the same units as your average or as your standard deviation would be. So what we're going to do to calculate the standard deviation, you're just going to do equals SQRT for square root. I'm going to go ahead and click on that square root because it already gives me the parentheses here. And then I'm going to click on that first variance value and then just click enter. And then it calculates standard deviation for you. And then just go ahead and drag that formula down into the next couple of rows. And then it'll calculate the standard deviation for the next few averages for you. Everybody with me on that, on how to calculate standard deviation? Okay. So again, standard deviation is just the square root of the variance. So again, in Excel, you would just type in equals SQRT, click on that, and then click on the variance right there. and then enter, and then drag it down, and it'll calculate it for you. So what you're gonna do with the standard deviation is you're gonna paste that into the same table that you have the averages. So what you can do, you guys can literally just Google the plus or minus symbol. So like I just Googled the plus or minus symbol right now, copied that, and then pasted that here. Everybody see that? So I pasted that plus or minus symbol, and then I'm going to go ahead and copy and paste the standard deviation. And it's in that table for you. That's a lot of significant figures. We're biologists. We don't need that many significant figures. We're not chemists. So just go ahead and round to the nearest hundredth. So 0.14. And then here I would just round it to 2.06. And then enter. So this is what it should look like essentially. So for true leaves, specifically the control, the mean plus or minus the standard deviation, and then you would just go ahead and do the same thing here. So go ahead and just let's get rid of all these sig figs first. So 3.54 plus or minus, and then the next standard deviation is 0.37 for the half strength solution. So just go ahead and type that in, and then there you go. Does everybody get that? So you're gonna do the same exact thing for all the variances for shoot height, taproot length, and plant mass. Once you've copied and pasted all the averages and calculated the standard deviation, let me do a new share screen, go back to that Microsoft Word document. This is essentially what your one table should look like. So obviously the average is super easy, you just gotta copy and paste that in, but you just have to calculate the standard deviations, which again is just the square root of the variance. And so in total, you should have 8 tables in your paper. So again, 4 of them are the ANOVA tables, the other 3 are from the post hoc tests, and then the 1 table with all of the means and standard deviations for each measurement and each treatment. So 8 total, and remember that you should have table headings that go above the respective, or sorry, actually, yeah, I think it's above. Yeah, it's above. So sorry, I'm actually wrong on this. So this should be up here. Ooh, bad. This should go above. So this table heading would be above this table. This would be above this table, so on and so forth. I have it in the PowerPoint, but this is wrong. This should go above. Okay, does everybody get that with the tables? Yeah? Okay, unfortunately, I'm not going to post this Word document because you could literally just copy and paste this and put it into your paper, but you already have your Excel sheet, so it should be pretty easy for you guys to make. I did record this lecture though with the scientific paper and how I calculated the standard deviations and made the separate tables, etc. So I'll post that on your Blackboard site just in case you need a reminder. I'm gonna go ahead and stop this share. But so remember that your papers are due Wednesday, May 6th, I believe. I think that is a Wednesday. Yeah, Wednesday, May 6th at midnight through Blackboard on Turnitin. Sorry, the sun's like coming through my window. But if you guys want me to read your papers before you actually submit them and make sure that everything is all good and that you have everything, you guys can submit that to me or email it to me early before you actually submit it through Blackboard. But the last day that I'm going to accept it via email to read in advance is going to be for you guys Monday, May 4th. So it'll give me about 2 days to read your papers. So your actual papers are due on Blackboard Wednesday, May 6th. But if you want me to read them and go over it before you actually submit it, I'm gonna accept them until Monday, May 4th. Everybody get that? Okay, cool. So that's pretty much all that I have for you guys. Hopefully that was helpful for your scientific paper. Yeah, that's pretty much it. If you guys have any other questions, just let me know. Don't forget to take your pre-lab quiz. And also don't forget that your lab 10 assignment is gonna be due next Wednesday by 4 p.m. this time. The only reason why I made it due by 5 p.m. today was because I know you guys had your practical first, but from now on, they're gonna be due right when class starts at 4 p.m. the week after. Also, before I let you guys go, let me just make sure that you guys know that, let me go ahead and go to my Blackboard really quick. Can you guys see my Blackboard slide? Okay, so remember that in Dr. Bobich's Blackboard site, if you go over to course documents and then laboratory exercises, he does post this document in both PDF and PowerPoint version right here that'll help you answer the questions for the assignment. So for example, like if it says, look at the life cycle of a lycopodium, he has the life cycle right here in the document to help you answer the questions. And then this is still loading, but pretty much he has all the photos on here to help you answer the corresponding questions. So keep that in mind. We are gonna post something like that for the next 2 labs as well. Okay, well, that's pretty much all that I have for you guys. I will stay on Zoom till about 7:30. If you guys have any questions, you guys can always log off and then come back on. So if there are no other questions, you guys are free to go. Stay safe. I'll see you guys next week.